So for this video, we're going to be deriving the area formula for an ellipse. So first of all, the formula for an ellipse is x squared over a squared plus y squared over b squared equals 1. Now, the first thing we're going to do is I'm just going to draw a little sketch of it. So that's it on a coordinate plane. We're going to focus on finding this part and then multiplying the whole thing by 4. So, first thing we're going to do is solve for y. Y squared equals over b squared equals 1 minus x squared over a squared. And there's a few more steps which can be done fairly easily. And you eventually get y equals b 1 minus x squared over a squared. Now, when you're taking this square root, it could be plus or minus. However, because we're focusing on the positive portion of the y coordinate plane, we can say it's positive. So now on defining the actual area, we're going to say 1/4 the ellipse area is equal to 0 to a, because we're going from 0 to a, ab 1 minus x squared over a squared dx. And this equals, okay, so first of all, to solve this, we're going to do what we've been doing in class and draw a triangle and say that this leg is equal to 1 minus x squared over a squared, the root of, so it's equal to that. This leg is equal to x over a, and this is equal to 1. So from this, we can say sine of t is equal to x over a, or opposite x over a over hypotenuse 1. Now we get dx equals a cosine t. Okay, so now we're going to go back over here and say the integral from 0 to pi over 2, which is our pi over 2 is this top part that we're integrating to, ab 1 minus sine squared of t cosine t dt. So this is because our 1 minus sine squared is from this right here, and then the cosine t comes from the dx. Now we go from the integral from 0 to pi over 2, ab cosine squared t dt. And we can say this because 1 minus sine squared of t is equal to cosine of t. And if you, so that comes from the Pythagorean identity that 1 minus sine squared equals cosine squared. However, if you take the square root of that, 1 minus sine squared equals cosine t. And if you multiply that by that cosine t outside of the root, we get cosine squared t. This is equal to the integral from 0 to pi over 2, ab, and now we're going to use our identity to do cosine squared t into cosine 2t plus 1 divided by 2 dt. And from here we're going to take out this 1/2 and go to 0 to pi over 2 ab cosine 2t plus 1 dt. This equals 1/2 ba the integral we finally take 1/2 sine 2t plus t. So we just integrated this inner part from 0 to pi over 2. Now we're going to we integrate from the limits of integration. Go 1/2 BA 1/2 sine of pi plus pi over 2 minus, if you put 0 in, that just equals 0. This is going to equal 0 because sine of pi is 0. We get 1/2 BA pi over 2. And this gives us pi over 4 BA. Now, if we multiply this by 4 to get our full area, because as you remember, we only did a portion of it, the top fourth portion. So we multiply that by 4, and the 4's cancel out, and we get pi AB, or the area of an ellipse.